Welcome to the ongoing series of science stories. Thanks for having me for this episode, and I especially thanks Dr. Banial for organizing this wonderful series. I am Pandini. I am currently a NASA postdoctoral fellow at NASA Marshall Space Flight Center, Huntsville, Alabama. As the format of this series goes, I will start with my childhood and narrate you the series of events which actually led me to take up the career that I am having right now. So I was born and brought up in Guntur. It's a city in Andhra Pradesh and the city where helium was first discovered in a solar eclipse event happened almost 150 years back. So I did my schooling in the Central Public School. So I did all my 12 years of schooling starting from kindergarten to the class 10 in that school. That's a wonderful school, and if I look back, I can relate most of the skill set that I learned that are helpful for me as I go along in my career are actually learned in the school, including the interest in the astrophysics or everything else. So I'm not so good with my academics. I'm average to borderline below average student in academics. But my school is very peculiar, so it encourages students beyond academics. They have so many extra and co-curricular activities. They used to have several events. We hardly used to go to school classes. There are good students who often go to classes, and then there are students like me who have some or other event as an escape and then start and go around the school with that event. And especially my family, it used to encourage me a lot. So though I perform very bad with academics and I often get a kind of not promoted level in the classes, so they never actually bug me with it. Especially my father, who encouraged me with other activities, he never asked me about how many marks you got. Of course he is concerned, my mother is concerned, but they know the school is not meant for getting good marks. They are progressive parents for that time. So especially the environment in our house is very helpful in doing good in co-curricular activities. At least we have a book club in our house. Every night we used to read a book. Actually my father used to read a book, and my brother and I participate in that. And then I do not remember any night in my childhood where this habit of book reading is not continued. So we used to read several books, mostly story books from various cultures from different parts of India, and we also read the Arabian Nights and Chinese books or traditional European books. So all these books not only gave us wonderful stories which are amazing, but also introduced us to different cultures. So this gave a fascination about the world. So reading storybooks doesn't just give you a story or a moral in it. It will also give you the culture or the timeline where the story is written. So this habit is that I got in my childhood from my father. I still continue. So this also led me to read more books as I go along outside my career. So this also gave us good knowledge about things around. So we also have huge debates and discussions in the house about several events that are happening around political, current affairs, historic. So we used to discuss several things, and then my father has a wonderful library in his house. So this will automatically attract you to at least open a book which is new, and then you get to know something about it. So this also led me to be an active participant in the quiz competitions in my school, and my school being very good in encouraging students in all other things. I started doing well in the school in every aspect except academics. All my teachers used to compare me with my brother, who is just 1 year senior in the school. You spend all that time in every other aspect, but academics, this will not help you. You should be good with academics, otherwise you cannot have a career. Well, they are true, but that's what I am. What to do? So I think it's in my class 8 where physics is separated from sciences. So the sciences is divided into natural science and biological sciences, physical science and natural sciences. So that is when I realized, wait, even in academics, something, if not everything, is interesting. I used to develop huge interest in physics. I don't know, is it because of my teachers or the natural interest towards the physics, but I started loving physics, and I also got introduced to astrophysics. This introduction is mostly from my books and also the documentaries series. So that was the time where Discovery and National Geographic used to telecast all their programs into the regional languages, and I used to see this Naked Science or Our Universe and many astronomy series, and I used to get super fascinated. Oh, what are they for real? I mean, the size scales they are telling, the objects they are telling, what is a supernova, which a star just blasts like a firecracker. Well, these are all pretty amazing stuff, and then these are all very close to you, in the sense you just need to look up, and then on the sky, whatever the sky that you are just seeing, all these things are happening. And those are the times we used to have a little better skies, not as bad as it is right now. So we can actually see many stars with naked eyes, and then like any other natural kid, I used to get super excited about astronomy. And unfortunately, we don't have more of curriculum in our textbooks according to, on astronomy. But I got this interest. I picked up it from outside sources. So my father identified this interest, and then he gifted me a book called Viswarupam. So that's a Telugu book written by Nanduri Ramohan Rao. So he's not an astronomer, he is a journalist, science journalist, I suppose. So he compiled several essays written on astronomy and translated them to Telugu, and then that's a wonderful book. I mean, that's a huge book. So that book for a while replaced our night book club session. So I still remember those nights where I can't believe what I'm listening, but because they are true, I'm more excited to learn more about it. So I thought, okay, I really wanted to go deep into this thing, but I don't know how. But one big hurdle is to become an astronomer. The only way you do is through the academic field, but I'm not so good with academics. So I used to read more books. Seeing my interest, my father started to give me more books, like Brief History of Time or The Universe in Nutshell. So all the Stephen Hawking's series of books. So I used to read all those books, and then keep on cultivating my interest in astrophysics. So in my class 10th, after my class 10th, I took mathematics, MPC, we call in Andhra at least. So well, I'm still not so good with my academics, even in my inter. So I have choice whether to take sciences or to engineering. I wanted to take science because I know that is the way you can actually take up physics and go to astronomy one day. But like most of everyone, I was forced to take engineering for several reasons. Like we don't have good Bachelor of Sciences colleges in our area, and people say engineering is better and you get a good job. I really don't have an option. I am forced to take engineering. So, but I didn't get good rank in MSET, which is the engineering MSET entrance exam. So I got something around 25,000 in the statewide. So forget, I didn't even think about IITs and AIEEEs. So they are two above my standard. So I just gave this local entrance exam, and I still got a 25,000 rank. So I joined this college called NRI Institute of Technology. So that is also in Guntur. So I didn't move out of my hometown until I finished my BTech. So I took electronics and communication. So I joined in 2008, and if you remember, that is the year where the huge recession happened in the world. And before 2008, the life is you take BTech, you get a job, and you get placed in Satyam, TCS, Infosys. These are the usual companies in our area back then, which come to your college and then give you a job and then take you away. So you will get job in the third year itself after 4 years. So this was the usual trend before that. But from 2008 onwards, things started to change south. The companies are not coming, and then there is BTech is not completely what do you say, perfect for taking up a career. So we had to worry about our careers starting from the second or third year. So starting from third year, all my classmates, they are choosing up their career. Some wants to write a GATE exam and then want to have an MTech. Some wants to try GRE. Most of them wrote GRE and then came to US now. And but I do not want to still continue with what I'm doing. Not because I didn't like my engineering. I actually liked electronics and communication. I did well even in academics for my BTech, but my interest in astronomy is still hunting me. And that was the time we got internet into the houses. If not to our cell phones, we have internet system in our house. So I used to spend more time in reading more about astronomy, and this time little more professional than just reading a popular science book. And then more I dig into it, I realized more I love it. So then I decided, no, I'm not doing the same mistake again. I'm not going up with anything else other than taking astrophysics. But I also realized that's already too late, because every career option that I see in astrophysics, they ask you at least to have a bachelor's in sciences, but I'm bachelor's in technology, so it's a compatibility issue. I was so depressed, but sometimes I even decided to again, okay, after BTech I will again do BSc and then do MSc and then come to astrophysics. So while I'm deliberating myself about taking a career in astrophysics, being an engineer, I heard about Indian Institute of Astrophysics, I think towards the end of my third year. And I was like, yes, I got this. I mean, this is an institute which has a program which will take BTechs, and then you can do MTech and PhD integrated in the astrophysics or related subjects. So this is pretty amazing. So I wanted to know more about that institute. So I went to their website, I saw the people list, student list, and then I got their email address there. So, and I wrote email to many students. Prasanna Deshmukh responded. I think you might have heard his episode of Science Stories last month, in the episode 6, I suppose. Yeah. So he responded to me, and then I said, yeah, this is my case. I'm so and so. This is so and so. My problem is I want to do astrophysics. Then he said, don't worry about it. IA is the best place, and there are so many students here from your category who did BTech and then came here. So this is a perfect place for you. So, and then I was looking what are the options to get into IA, and then the one suitable option for me is to write a GATE in electronics and then get an interview there in IA. So I was preparing for GATE, and I mean, I know then that's the only option that I have. So I didn't think about anything else. But towards the end of my BTech, I got a couple of job offers from software companies. Then that is the road not taken moment for me, where I had to choose whether to I take up a job which I already have in hand, or leave the job and then start preparing for GATE, which I am yet to crack. So, but again, my family stepped in and then they helped me, they guided me, they said, don't worry about all these things, your career, I mean, what you like is more important. They guided me towards it, and then, they actually supported me in taking my decision of leaving the job and then continue with my exam. And then I got good rank in GATE. 96 percentile is the limit that IA has cut off for interview, but I got well above 99 percentile, so I was happy. And I again contacted Prasanna saying that, yeah, I got this rank, I think now I'm eligible for interview, so what to prepare for interview? Then he said, focus more on electromagnetics and optics if you know some of it. So these are the things that they usually ask. So now I know what they are going to ask in interview. So I prepared well, I did good in my interview, and I got admission. And I also got admission in a couple of other institutes like IITs. Then again, some are suggesting me, these IITs are popular, we know them, but we don't know what this IIA is, and you are saying that is a 6 years course. Is it feasible for you? It's like, no more decision, no more deliberation now. So I joined IIA in 2013, and have 4 other colleagues who are wonderful colleagues. So we had our first year together in Calcutta. I mean, we all stayed in a house by ourselves. We are managing, I mean, we are absolute strangers, but we were kept in a place. I call it hostile condition, because we are new to the place, and then we are new to each other, and then have to manage house. For me, it is especially hostile, because that's the first time ever I'm staying outside house. So it's not even a hostel life when I went to Calcutta. It's again another house life, but with strangers. And then so we had a wonderful time. And Calcutta University is where we get our first year coursework, is also a wonderful university. We have some of the amazing professors who are the authoritative in the field of optics. So they teach us optics and electronics. Though we were in IIA and we can call ourselves astronomers or astrophysicists, we know that our job is to actually build an instrument or instruments for astrophysics. So we are more of engineering side of astronomy. So we know optics is very important for that. So we liked our first year. I mean, you ask any of our MTech PhD students, they say one thing for sure, that the first year is amazing, we learn. Because none of us has optics experience there, so we go there at MTech level, we get to learn so many new things. So that is pretty amazing. So after first year, we came back to IIA in Bangalore. So we have 3 years of internships where we get to visit different field stations and then get introduced to the real life of an engineer or an astronomer. So that are all like virgin experiences. This is the thing. Okay, this is the telescope. Okay, so far I heard of big telescopes, but when you actually go to Kavalur, then I realized, this is magnificent. So these are all, I would say, the lifetime experience. I mean, you need not be an astronomer or be a person pursuing a PhD in astrophysics or a professional astronomer. As a usual enthusiastic person, these places are should be a tourist places. I mean, off seasons you should actually go to these places and then see these, visit these facilities. So you get to appreciate the scales and the efforts that people do in astronomy to just get some small data. I mean, astronomy is an amazing subject where we talk about every biodata of that star or a galaxy or anything, or anything in the sky, but we actually don't go there. What we get is a few photons, few tens of photons, and we receive the photons and then study the whole properties of that star. So I got a wonderful feeling when I actually went to these observatories, and then I realized what is the kind of job that I am into. So these 3 months are pretty useful career in the career aspect. So after that, I choose a project which will be continued for my MTech dissertation as well as the PhD project. So I choose to work on X-ray optics. This is a project proposed by Dr. Shri Kumar and Dr. Shama from ISRO. So they were working on developing X-ray detectors, but now they wanted to initiate a project where they want to develop X-ray optics. So in astronomy, we have two parts. One is the front-end optics and the back-end detector. It's like a camera now. So you have a mobile camera. What you have is a set of lens, which we call it as optics, front-end optics, and a detector in the back. So when you say I have like a 20 megapixel camera, so what you're talking about is the detector part. But what actually decides the quality of your image is the front-end optics. So that's the same in even in astronomy. So we have to build huge and wonderful telescopes, telescope optics, and then have it detected the focus. So just to give a introduction or motivation about my project, you know, the electromagnetic spectrum, they range from gamma rays to radio waves. So what we see with our visible eyes is the visible light, as the name says. So when you see a star up there, what you see is a visible light, because number one, your eyes are tuned for visible light, and number two, visible light only visible light enters our atmosphere. And of course radio, you can't see radio waves. So but if you see any particular star, they also emit in all other electromagnetic spectrum. So they emit in gamma rays, x-rays, and to the other end they emit in radio waves. And the reason why it emits visible light is not the reason why it emits in other wavelengths. In a sense, a star has different mechanisms for emitting different radiation. So one has to study a particular object in all the wavelengths in order to understand the complete picture of that particular object. So my job is to work on developing instrumentation to see X-ray telescope. So why X-rays are challenging? Because X-rays, the wavelength is very small. Means if you keep an object, the wavelength of the light is comparable or smaller than the size of atom inside the material. So it doesn't matter what material you keep in, what it sees is only atoms, and then it will easily penetrate through the atoms and then go. So they have high penetration power. That's why if you have an X-ray for your body, so what you have is they penetrate through your body and then give the whole image inside your body. But for developing a telescope, that's a negative aspect, because we need a mirror to reflect X-rays, not which penetrate. So developing a mirror which actually reflects X-rays is a challenging task. One way people do it is instead of bouncing off the mirror in the perpendicular axis, they actually tilt the mirror and then bounce it with some grazing angle. It's almost like when you drop a stone into the water, the stone just goes into the water, it penetrates through the water. But when you throw it with some angle, it bounces back. So the same way we have these bouncing mirrors with certain angle. These are working good, and then people have figured it out several decades ago, and then they have wonderful telescopes made. But the real problem or limitation is these kind of mirrors, they are very heavy, bulky, and expensive and whatnot. They are also the imaging quality is also not good. So the goal of my PhD is to develop some kind of mirrors which will reflect X-rays at higher angles. So for this, the technology that we adopted is developing something called multi-layer mirrors, where we have different layers of materials deposited on each other. It's a thin film technology. So when X-rays bounce at a higher angle, so as it penetrates, it has to encounter several layers, and then at every layer we'll have some reflection. In the aggregate we'll have a higher reflection. So the real problem I faced in my PhD is I'm the only person in my institute working on X-rays. So no one understands my problem clearly, nor there are any facilities which can actually fabricate these kind of mirrors or test these mirrors. So, but thanks to my guide who's extremely supportive throughout the PhD. So he hooked me up with different institutions across the country and even across the world, where they have facilities but use them for something else. So he started a collaboration so that I can visit their labs and then work with them and then use their labs and then get my job done. So I often go to RRCAT in Indore, BARC in Mumbai, TIFR in Mumbai, and PRL in Ahmedabad. So these are the institutions where they work on different problems, but they have a technology which can also do something for our requirement. So this is a kind of wonderful experience where I got to visit several labs, some of the best labs in the country. So this is both an advantage and disadvantage. So the disadvantage part is because you have to go visit different labs to get your job done, you may have to wait for everyone's availability. It's not like I just go and then they will provide me all the lab facilities, but we actually have to wait for their availability. But on the brighter side, I get to visit different labs and they work on different problems. It's not the kind of problem that I am doing on. So for example, if you go to RRCAT, people work on laser technologies or synchrotron technologies or material sciences. So I also get to talk to those people and understand their problem and see how they are approaching their problem, and what else can I learn and apply it to my own problem. So this diversity is something that I'm really blessed to have during my PhDs. I mean, frankly, it's not very easy and a natural thing to get so much diversity while you're in PhD. You are mostly focused on your single problem. So this gave me introduction and appreciation for different technologies and different people and different working styles. Also, it has another bright side. So when I have to wait for getting my job done at different places, I have a lot of free time. So I can actually use this free time to learn or initiate a project which is outside or slightly different from my PhD project. So while my major goal is to design, fabricate and test those mirrors, I also started to look into the kind of applications that I can do for these mirrors. Yes, one application is what my PhD problem gave me, to have a wonderful optics system which can which is compact and then can have a better imaging performance. So when I was reading more into the literature during kind of free times in the PhD, I realized there are several applications with the kind of mirrors that we are doing. So one thing I realized is one can develop a polarimeter for X-rays using the same mirrors that we are doing. So several groups are working on this technology. So I thought maybe we are having the same mirrors and we have the same facilities. Why also not look into the polarimetry aspect of this mirror? So this is just an example that I'm giving. So PhD time, it's always important to get the overall holistic view of your work. Yes, when you actually sit in the lab and when you actually tackle your project, you will be so narrowed down to the point, but there should be certain intervals where you have to stand back and then take 2 steps backward and then see the holistic picture and then get what else you can contribute to the system close to your vicinity. So in this way, I got some people working on the polarimetry. I contacted a professor from MIT who is working on this problem, and then I made some designs and then contacted him, and then he actually liked our work and then he collaborated with us, and he even invited me to his lab. So during my PhD, I actually went to MIT labs and then worked there and then tested my mirrors there. So these kind of aspects is what I call I rate my PhD as the wonderful experience. Yes, I mean, every PhD is wonderful in the work they do, in the kind of papers they publish, in the kind of new technologies they find, and new methods they find. But for me, they are there, but it's more about the kind of collaborations you make, the kind of people you meet, and the kind of holistic understanding of your own subject along with the other subject. So as a person who visited several institutions in my PhD, I can confidently say IIA is the most joyful place to have your PhD. We have 60 odd students, and we have wonderful faculty, and we have very supportive administration. So this made the whole experience very joyful. We have so many students, so we have so many activities popping up every day. We have people from all around the country, so we celebrate festivals together. We celebrate from Onam to Durga Puja all along, and so we have so many cultural activities going on. We also have so many musicians, so many sports players. So every night we will have some or other event, and every now and then we will have joyful events. And we often go to trekking, we play sports, and of all the best one is the IA outreach activities. So they are pretty amazing. So students, faculty, administration and the whole system came together for these activities. So we often go to schools, teach students, take our telescopes and other equipment, and then give them hands-on experience or invite students to our institute and then give them hands-on experience and then explain them, show our labs, or train the teachers. We invite the teachers and then have this teachers training program or competitions. So it's a regular ongoing activity. Because we have so many students, so one need not invest so much of their own time in order to organize this outreach activities. We'll have so many people involved, and then we just need to give a little contribution, and then we'll have wonderful outreach activities going on. So while I'm in these outreach activities, I realized it's not just kids for whom we need to properly educate the science. I mean, kids are great. They are natural enthusiasts. We need not tell them how to be interested in anything. They are already preloaded with a lot of interest. So what we just need to do is we just equip them with some information and just answer their questions, and they will be satisfied. But certain real problem comes with grown-ups. For example, whenever we go to the public outreach sessions, outdoor outreach sessions, if there is a school kid, the kind of questions we get is, okay, what is a black hole, what is the space-time relativity, how the time dilates with the gravity. So all these pretty advanced stuffs. But whenever an adult comes to us, and then the kind of questions that we are shoot at is, is astrology true? Can I eat or drink during an eclipse? So is it really two big snakes eating the sun during the eclipse? So these are the kind of questions. So yes, we can answer those questions, but the real problem is what is giving those questions for them. So we see there is a huge bifurcation in the society about the people who believe in science and people who believe in pseudoscience. So one can confront with each other. I mean, for example, as a person who does science, I can just go to them and then say, hey, you know what, whatever you say or you're saying is everything wrong. But the point is, the moment when I confront people saying that their belief or understanding about certain scientific aspect is not correct, they counter me back, and instead of having a healthy conversation, we often end up debating about certain things without taking each other points. Then I realized one needs to have a real skill in communicating science. I mean, what's the point when he don't even listen to you in your first word itself? You can't communicate your actual point. So then this really bothered me. So I thought as a side career, I should be serious about communicating science to the people, not just children or the school environment, as a society as a whole. So last year I started a science journalism course. So I'm almost done with the course now. So there is this Indian Science Communication Organization, so which give you a degree in science journalism. So I have registered for it and then finished the course recently. So the main motivation for me to do a journalism course again came from IAEA. So had I not been involved with outreach activities, it wouldn't have triggered my interest or my concern to communicate science, whatever I can communicate. I know there are wonderful people working out for science communication. I just wanted to assist them and be a communicator, or try to be a communicator myself. And I must say, IA has been a wonderful part of my career. After defending my thesis in the early 2020, I joined a short postdoc in Norway and then moved to USA for NASA postdoc starting from this year. And it's been 1 year I left that place, but I still miss that place. I miss my friends. I rather prefer call it my family. So, and I'm sure I always want to be part of IA family. So this is my science story, and thank you.